So start with this. The next one is what we are having is this IoT mobility and settings. So this is the next module where we deal with the sensors which are working in a mobile environments. And in last lecture, even I briefly discussed the concept of this handover. So this was one concept where sensors or this mobile networks are there, and this mobile network have got their own, what you can say, area. And when one sensor is there or one IoT node is moving from one network to other network, so their coverage is having some, what you can say, range, and from one range to other, when you actually travel this sensor is, then it has to be properly, what you can say, given handover. That is one concept. Other concept of importance in IoT is the localization. Localization means when you are having a sensor over what you can say given proximity or area, then in that proximity or area what we are having is that locate the sensor, because in case of this mobility is there, then to take decision or to give service for that specific sensor requires a precise location of that sensor. So how to get that? So you may say, sir, GPS is there, we are having mobile phone and that has got GPS that gives me accurate location, so we can use that. So this is the question, and whether this is a valid solution or not, let us see, let us discuss. Okay. So yes, that's why in this module we are having localization, concept of localization, then mobility management. So we have seen this means when the sensors are on the move, we have to provide them with this connectivity. Then localization and handover management, as I just discussed in previous lecture, handover. Today I just briefly gave the concept of localization and management of that, how this actually uh, sensors which are there when they are actually moving from one to other. So how to locate them, how to manage them, that is important. And then identification of IoT, this what you can say, data formats are there, the IP address assignments, or beyond that, if I want to. So we have seen this thing in first what you can say, first module, that IoT identifiers are there. Hmm. IoT identifiers are there. So this concept is revisited here. This concept is revisited here. So briefly, we'll revise that. So idea is that we are having traditional localization technique. Location, what you can say, not management. You have to locate the technique. So localization techniques. So GPS global position system is there. It is using, what you can say, satellites. So our Earth is there, and then we are having three satellites are required. Out of these three, even if this device is connected to any two, it can locate itself. So all over the Earth, these three satellites uh, using this positioning kind of thing, positioning of satellite signature signal strength. This device, a person on a, what you can say, a specific location on Earth can be identified. Okay, there are longitude and longitude, and using that uh, this system where you can actually locate us, what you can say, a part on Earth's surface precisely. See, GPS system, they have accuracy up to 1 meter for military uses, and for commercial up to 50 meters. Both the things are there. So this is the idea, and this is one of the techniques that is used. But for for our deployments, which are here, it is written WSN. But when we have our IoT deployment, okay, so what we are having, we are having large scale deployments, and we need to go for simpler or cost effective devices. And beyond that, we have to go for energy conservation also. So all these things if we consider, all these things if we consider, what is that? First is large scale, second thing is, so what you can say, cheaper, and third thing is cost effective, you can say, and third thing is energy efficient. So energy efficient devices. So all these three conditions if you want to satisfy, and deploy a sensor which can be part of our IoT deployment, then the conventional this technique GPS, this creates a problem. Problem in the sense that for small this GPS chip, then calculation required, the resources required for GPS sensors, they maybe energy conservation we can go for, but large scale and cost effective it becomes a problem because there these sensors are costly, this electronic device is costly, and maybe inside premises or kind of thing, or when you need what you can say large scale deployment, then in that case for that what you can say uh, problem domain it may not be that much what you can say readily suitable. So for that purpose we have to go for some techniques which are alternative to GPS. And remember for this you see on the screen, that is range based localization and range free localization. So in some or other way they use radio frequency waves, RF signals, RF waves, and additional hardware alongside this. So antenna, then transmitter, then receiver, and combination of this thing. Using this thing in a what you can say, if this is your geographical area, then you can locate a device sensor S1, for example, location of sensor S1 precisely. Okay. So for that purpose, yes, range based and range free, these two techniques are there. Range based localization, as I said, is additional hardware and it uses some of these algorithms based on the signal strength, signal angle, whatever it is received to calculate a device location. Okay, so whatever antenna you are having, from this antenna, if I want to locate this, okay, it will be having this, it will calculate the signal angle and all things. Then next is range free localizations, where it will need if you are having the sensors deployed, then these sensors deployed, they will be connecting to edge devices, their location, their name, if they are if static and dynamic both, if they are what you can say having some characteristic of what you can say placement, so like S1, S2, S3, S4, S5 kind of thing. So based on the signal, what you can sensor name, I will be able to what you can say decide the location of that sensor. The characteristic of network connectivity kind of thing, from where the signal is coming from, how the signal is coming. So this comes for 2 to 4 marks in the exam. Remember this thing: range-based localization and range-free localization. These are the two key techniques for sensor localization. Okay, so here you can see this what are the different parameters which are count by range-based localization. Okay, so here you can see that the calculate location from what you can say measurement technique like received signal strength, then time of arrival, then time difference of arrival and angle of the arrival. So for example, if two sensors are there and this is the antenna, and then for example the signal this angle is there, we can say angle of arrival AOA. Okay, and this signal S1, signal S2, if I am able to find what is this signal S1 and signal S2 and how their difference is there in maybe milliseconds or microseconds, and angle if I am having, and signal strength, I know that every each of my signal, each of my sensor, they are maybe transmitting with 10 decibels kind of strength on. If you say the milliwatt power or 10 microwatt power and whatever signal strength is there, so that will be used. So multiple parameters, as I said, that parameter one signal strength, time of arrival, time difference of arrival, angle of arrival. Using this thing, there is a it will triangulate. It will triangulate to find out what are the locations of the signal which are coming. Actually, this is used in military. Those who uh, want to have what you can say details, so we can just go on Google and search. But I can just briefly give that. So in this radio transmitters are there, and they use AM waves, so analog radio transmitters. So we can actually use triangulation technique to locate where this transmitter is coming. So in military, if someone is using radio transmission to leak your information, we can use this technique to find that location, or maybe the not precise but actually probable location of that transmitter in very big, because this region might be squares of kilometer, or like a city where this kind of transmitters are used. And then this method can be used to triangulate the position of the transmitter. So same similar technique can be seen here. So range based algorithm for range free, calculate information from connectivity information. Okay, so this connectivity information here you can see. So area, hop count, neighborhood, and they are coarse grain. Means this kind of this location identifying approximate. You won't get no what you can say precise location of sensor. But here range free, here you can see ranging the location, distance, angle. These parameters are used with along with algorithms to find a precise location of the sensor. So maybe they say this thing as fine grained location. So remember, so in this range free, in the we have seen that just now this no subscribe, and then in that subscribe packet we can put now area, then no hop count kind of thing, and when this one sensor gets that, we can update that thing and relay that information. So like this thing it goes on, and we can find the post grain, what you can say, information and fine grained information. So remember this thing. This is the question for 2241. Localization. So why localization? I told you to know what is the precise location of that signal. How it will help? So if you want to generate a heat map of a specific area or for a specific city, and in your city you are having this sensor deployed. Okay, if there are fixed, very good. Then using this area of count, you will come to know from which area, which sensor, and then you can generate heat map. If there are in movement, then using this fine grain techniques, if and this needs additional hardware, but you can also take, you will come to know this reading is coming from this area. So then you can put it on a map, and you can have the live, what you can say, picture of the temperature or what the physical quantity you want to measure. Maybe like in Google Map, you are having, they are using GPS, and using GPS this traffic information is found out. So, like that is the thing. But as we have started with that, GPS may be the costly solution for your problem, so we have to go for alternative ways. Okay, so here you can see what are the frequency ranges. Actually, we have seen this thing, this communication bands. Okay, so these are the various possibilities for a sensor when they are actually communicating with each other. So sensors might be communicating on various frequency range, sub-gigahertz, gigahertz, and millimeter wave. So here you can see 5G and others. They communicate on millimeter wave, 2.4 gigahertz or higher, or 4 gigahertz or higher. Gigahertz, here you can see Zigbee, LTE. So these are the common standards. The gigahertz range, sub-gigahertz, RFID, LoRa, Sigfox. These sensors they communicate on sub-gigahertz range, means 900 to 1,800 megahertz range, 2 to 4 gigahertz range, and 4 to 6 gigahertz range. So in license wise, so unlicensed band, so we have seen this Eisen bands are there for a majority of sensors. They use this unlicensed band. Even your RFID, your fast tag, they use unlicensed band. Common use only available used for general communication. And licensed bands are also there, cellular bands. So Sigfox and others, ILT, long-term evolution signals they use, like Geo, 4G, Geo 5G, Airtel IoT kind of thing. So that is the idea. Okay. Then standard wise, so IoT specific protocols are there, which can be used by the sensors, or IoT enables Bluetooth Low Energy, Wi-Fi, 5G, Telensa. These are the standards for IoT communication. Various ranges possible. So personal area network, wireless personal area network, wireless local area network, wireless wide area networks, and depending on what communication techniques and standards they are here for the sensors. So even in the city you can connect using wireless wide area network. For a typical building or typical complex you can go for wireless LAN, and for a small area, small room, or small ground kind of thing you can go for personal area network based deployment, low rate transmission, high rate transmission. Okay, 5G typically 4 to this high rate, Sigfox Zigbee for low rate power, low power transmission, high power transmissions. So various possibilities when IoT communications are there, IoT sensors will communicate depending on their mode. So next topic that we are starting is actually mobility management. So so today purposefully I started I think at 11:15, 11:15 a.m. right? 11:15 to 12:15, 12:30 to 1:30. Yeah, I'll continue because yesterday actually I had some last minute work and I could not take the lecture. So sorry for that. We'll go ahead with this. So mobility management. So next is this briefly I discuss, but again let us refresh. So what is why mobility management? I want to, yeah. So here you can see the cell CI cell CG. So what happens when you are having your GSM, GSM area GSM distributions? They are actually organized in a cellular network. So that's why when you have your mobile phone, you say that it is a cellular phone. Why? This is the reason. I don't know how many of you know this thing. Yeah. So it is like honeycomb and in sections in a typical honeycomb. Okay. Here you can see one on the side. So it is now if you think of no like no city like Mumbai, so maybe it is like no Bandra suburb, and this actually these cells are very small, but I am just for your example Bandra, Khar, Santa Cruz, okay, then Mahim kind of thing, and the nearby suburbs. If you talk about Ratnagiri, where we are taking lecture from, so Ratnagiri, here we are having MIDC, then you are having JK files, then you are having Maruti Mandir, then you are having Tokan Nagar, kind of thing. Then here you are having Nachme. So this is actually real thing because here the cells are quite small. So typical cell radius is 2 to 3 kilometer maximum. Very small cell areas are there, and it they are actually designed or they are mapped in an hexagonal. So each cell looks like an hexagon. Yeah, like something like this. Why this? Why? Because this area, all part of our typical area should be covered. So hexagon won't keep anything in between. It will be everything will be patched together and it will cover full area. This is the idea behind a typical cell having hexagonal shape. But in reality, they may have some overlapping kind of thing. Okay, they may have some overlap because in reality they are not like something like that. Something kind of this thing. It goes on like this thing. Okay, these are the so cell one, cell two, C1, C2, C3, C4, C5, C6, C7, kind of this is, and there is a concept called as frequency reuse. Why? Because now this cell frequency is F1, then F1 will be used here. Here it is F2, F3, then F4. So it will use here F1 here. F1 is here, so F3 here, and then F2 here, maybe F6 because F2 is here actually adjoining. So that see typically every this communication channel provider they are having 5 megahertz frequency band allocated to that carrier, and typically this they are having these sub carriers or sub bands are there, and these small bands are allocated to each and every carrier. And as now this is only 5 megahertz bands, or even maybe for this was for GSM, for 4G it is using wideband CDMA, WCDMA. So concept is different. So I'm just talking about GSM systems. So different frequency and frequency reuse concept is used. Now what happens when you obviously it is mobile phone network. So from one cell you will be moving or roaming to other cell. Moving, I don't say roaming because roaming comes when two cities are there. So moving between, you are traveling in a car or on a bike, and then you are moving from one area to other, or on a train or on a bus. So you see that now, as now here frequency is different, coverage is also varying. And then from one cell, when you actually, and every cell will have a base station. BS, here you can see base station can be seen, base station can be seen. And this base station is having the record of the users, which is actually are there, which are connected to that. Then it is connected to master, what you can say, was central switching session, then master session, and it is routing the communication. It has got it transceivers, which will gather the signal, which will transmit the signal, and will be connected to your handset, kind of things. So lots of things are there at the background. The details are very difficult to put it on the screen. But here, the hexagonal structures are there. User movement, if you want to go from one cell to other. So it will have to switch between this sub-frequency band. It will have to switch between this base station, and it has to happen seamlessly. And this process is called as mobility management. Is to make this thing happen. So it doesn't happen that when you move across the network, or when you move across the terrain, your signal drops. Okay. So typically when you are moving in a train or in rural areas where the network density is not that, like metro cities, it happens like in Ratnagiri, students are there. When you travel in the this Konkan railway. So when the train goes in the tunnel, then you lose your connectivity. Or so nearby the urban areas, the connectivity is there. So device loses connectivity. Why? Because signal strength goes down. Signal strength goes down. So idea is that here we are actually mentioning this thing for typical GSM network. Okay. So here another thing is UMTS, Universal Mobile Telecommunication System, UMTS network. 3G, 2G, 3G systems are there. UMTS. Okay. And with mobile phones to work, the aim of mobile management track where the subscribers are, allowing call, SMS, another mobile phone to be delivered to them seamlessly. That is very important. Then location registries are there, signal strength meters are there. So various, what you can say, uh, features of this mobility management. So experience enablement. So whenever this augmented content and aggregation delivery, so the delivery should be seamless. In vehicle services, because your mobile phones, your devices, your connected car, your smart IoT sensor, they are on movement. Then maybe you are pushing, what you can say, content which will lead in what you can say, which will lead to advertising of specific products to the related to specific area. Okay. And cross device identity management. So maybe you are logging to your mobile phone and laptop, and your mobile phone connected to your car, and then when you are moving and coming, then it should be cross device. If some information is to be exchanged, then it has to be managed. Then consumers, so mobility as a service. Now seamless experience to the user. So from laptop, you can check your mail on your mobile phone, or if you are on a train, then you can, WhatsApp allows you to call from your laptop. So yes, they are actually seamless, having seamless experience, relationship and data collection, ready to analysis from that traffic data or any other user data. Then infrastructure enablement is required. So for users to experience seamless mobile connectivity, then ubiquitous technology that is available and acceptable by all the users. Then vehicle to anything, which is connectivity. So as I said, smart cars, this is relevant. So vehicle to anything, X connectivity. Then seamless interoperability solutions and traffic management. Things are there. Then over the air software, what you can say, update, machine learning, analytics for data which is there, and advanced sensors deployment and connectivity for your overall IoT, mobile IoT scenario. So on the screen you can see a typical, see in India now Reliance, Jio, Airtel, both have been working on this enterprise mobility management. Even today there was news that Starlight Technologies, they are tying up with VMware for end-to-end mobile 5G mobile connectivity softwares. Okay, because when enterprise will adopt, they can develop end-to-end solutions. Enterprise like banks, this Reliance retail chains. So when they are adapting this thing into mobile solutions, it will reflect in the our day-to-day life and beyond. So even for enterprise needs, there are various what you can say applications which need mobility management. Okay, so like in IT, there is work from home, and your this developers and testers they are on the move. So for that purpose, they need to be properly connected. Okay, so that's why you can see one end is device end and other end is application end, which is at the enterprise servers, and they are connecting through the various levels. So here you can see software level is there, which is managing this device and application running on the device. Then this APIs and connectivity enablers for this enterprise server. So here we will have servers and hosting the services which will be given to the devices. And then in between IoT platform, IoT APIs are there, which are enabling the smart, what you can say, applications. Okay, so authorization, then connectivity and data exchange for MQTT, XMMP, and transport protocols, then device management plugin, and all this ecosystem gives what you can say gives you an experience of the smart application deployment, smart application management. Okay, so today we'll stop here.